Hey guys, this is a small video about the growth rates of products and ratios. So since we're introducing in the solo models per capita terms, and then we're going to introduce technologies as well. So these are going to be very handy. So here they are. So in discrete term, assume that I have some variable here. That's actually so it's going to I'm going to put everything into one formula. So it's a product of xt and yt and divided by zt. So it's a product and a ratio. Then in discrete term, if I want to look at the growth rate of v, so delta vt over vt, so it's going to be approximately equal to the growth rate of x plus the growth rate of y minus the growth rate of z. So that's what you have to remember. So if it's multiplication, you add them up, and if it's division, then you subtract. So it's pretty simple. This is true, it's approximately true for small values of delta Vt over Vt. So if we're considering either very small growth rates or growth rates over small time intervals. In continuous term, then this is exactly true. So if Vt is, again, x of t, y of t, z of t, note that here, instead of indexing by t, we just assume that v of t is a function of time that we can evaluate at any value of time. So if it's, again, the same expression, so x times y divided by z, then the growth rate of v, so v dot of t divided by vt, which is dvt dt, then is going to be equal to the growth rate of x plus the growth rate of y minus the growth rate of z. So you shouldn't trust me just by what I say. So I'm just going to show you a small example. So just the multiplication, it's an easy one because yeah, I don't want to work too much. So imagine that vt equals to x of t, y of t. Then the expression dv of t dt divided by v of t is going to be equal to, now what I can do is simply substitute v of t by xt y of t. So it's this expression dt divided by xt y t. And this is just at the numerator, I just have a simple product derivative of a product. So it's going to be equal to dx dt times y of t plus dy of t dt times x of t. And this is divided by the same thing, xt y of t. And it's very easy to see that here the yt cancel out, and here the xt and xt cancel out. So what I get is dxt dt divided by x of t plus dy of t dt divided by y of t. All right, so now you trust me that it works, like at least for a product. So I invite you to check for a ratio. Now I didn't do it for discrete time. which would be more useful since that's what we use in the present solo model. But I didn't do it because it's long, so I'm just going to show it to you what it means. So if I have, and let's do it for a ratio this time, division. So Vt is capital XT divided by capital ZT. So what is delta Vt divided by Vt? Well, it's equal to delta Vt is, again, as we said, Vt plus 1 minus Vt. So I'm just going to replace Vt plus 1 by Xt plus 1 divided by Zt plus 1, and Xt and Vt divided by Xt. Vt is replaced by Xt divided by Zt. And now I'm going to put terms together. So first of all, I'm going to multiply everything together. So Zt plus 1, here I multiply by Zt plus 1 divided by Zt plus 1, and Zt I multiply by Zt divided by Zt, so I get this expression here. And here I'm just going to multiply by the inverse of this, so Zt over Xt. And now what I can do is say the following. So Xt plus 1, what is it? It's actually Xt plus delta Xt, because delta Xt is Xt plus 1 minus Xt. And Zt plus 1 is Zt plus delta Zt. And then I keep the rest together. Now, all I do is I actually do the multiplication. And as you're going to see, that there's this minus xtzt here and this xtzt here, so these two will cancel out, and in the end I'm going to get so I can simplify the expression, and in the end I get what? Delta xt over xt minus delta zt over dt, but multiply by this term here, zt over zt plus 1, which didn't disappear. Well, it was a result of this zt here. So you see that it's not exactly equal to this expression, but if the growth rate is relatively small, or t is relatively short, then zt divided by zt plus 1 should be close to 1. So we can say that this is close to this. Now, in the solo model, we are going to abuse notation and say that this approximation here, we're going to not consider it. However, keep in mind that to be absolutely strict, then we should always keep an approximation there. But you're going to hate me if I keep approximations everywhere, so we're going to stick to equal signs.